All right, good morning, everybody. Welcome to the Ceph Day and surviving to the final day of OpenStack. Always an accomplishment. I think we lose about 30% of the people along the way. But thank you very much for making it this early morning session here. Three of my friends from Red Hat here are going to talk about CephFS, which is something we haven't heard a lot about in official talks lately. So this is going to be exciting for me, too. So if you guys want to take it away, introduce yourselves and give us the lowdown.
Sure. OK, so texting works great. So welcome, everybody. Today we are going to talk about CephFS, as our colleague says. The title of our presentation is CephFS by NFL Shared Service for Multi-Tenant Clouds. And my name is Victoria Martinez de la Cruz. I'm a software engineer on the OpenStack Manila project.
Hi, I'm Ramana Raja. I'm a software engineer at Red Hat. I work on integrating CephFS and Ganesha with Manila.
I'm Tom Barron. I'm a software engineer at Red Hat. It works on Red Hat OpenStack. So I'm working on integration and turning this into a Red Hat OpenStack product.
OK, so the content for today is split in 4 sections. First, we are going to start with a brief overview of the key components. We are going to go over the tools we choose, why we chose them, and well, maybe say a few words about the latest updates of them. Then we are going to cover the current state of CephFS as a native driver. Then we are going into the current state of CephFS NFS driver. And we are going to end this talk with a brief discussion on the future work and the working prototypes we have, and well, put you on context of what our plans for the next releases. So what are we doing here, right? It's like we have several tools. First, we are going to talk about Manila. Then we are going to talk about, well, CephFS, and finally about Ganesha. The idea of this whole presentation you're going to see today is to have NFL shares backed with Ceph storage and have consistent access in the cloud through Manila. So first, let's talk about OpenStack Manila. OpenStack Manila is the shared file system service for OpenStack. Basically, what it does is offer a set of APIs for you for tenants to request the system shares. It has support for several drivers, so some of them are proprietary, but there are also open source options such as the CephFS driver, of course, and the so-called generic driver, which is on NFS on Cinder volumes. This is a reference driver we have, and so you will see it mentioned all around. That's what it is. And why Manila? OK, that's usually more related use case of this project. So first and foremost, file-based applications are not going away. If you want to run those kind of workloads on the cloud, it is really useful to have a service like Manila to get your shares on demand. Apart from that, it's very useful from the interoperability standpoint, since you can access different storage systems with the same API. Also, we have to mention the rise of containers. That's a super fancy way of putting it. But what it is that everybody is using containers. Everybody wants containers. Like in this conference, you have heard containers so much. So how many times? Like all the talks were about containers. And we have to remember that the storage in containers is no more than a file in a file system. That's the volumes, but basically what it is in containers world. And finally, the concept of permissions. That is a very useful concept that we handle in file systems. And it applies to several use cases for current workloads you are going to run on the cloud. Now let's talk about CephFS. Ceph probably needs no introduction by now, but basically it's a free and open source storage platform that implements an object storage solution and provides interfaces for the object block and file level storage. Let's focus only in that section in the right, CephFS. CephFS is a distributed POSIX file system. You have different clients to interact with it. The most basic one is the kernel client. You also have libCephFS, and you also can interact with Fuse. And yeah, well, that's pretty much it about CephFS what I wanted to say today. So let's move to why CephFS, which is, I think, more important. Here we add a graphic that we got from the user survey that shows that most of the users of Manila right now are choosing CFFS over other file system solutions. I don't want to lie off here, like this is the numbers as we see them, but I want to make the note that this was a really small set of people that it was asked. It was, I think, 31 users that actually answered the question, and maybe it was not the expected people we wanted to ask for those questions. Mostly was developers. But this shows a tendency that like CFFS is being adopted, and that's what we expect to see in the upcoming releases. This is also the same for Cinder. In Cinder, you're going to see a really similar diagram. You can access the whole numbers and everything in the link we have down there. So if your cloud already has Ceph as a storage solution, why you don't leverage CFFS for file systems, right? It makes complete sense. Apart from that, it's open source. And it makes sense to have your open source storage solution for your open source cloud solution. Also, it provides scalable data and metadata. And of course, it's POSIX. So I think it makes complete sense for those reasons. Now let's talk about NFS Ganesha. It's the last piece of our combo here. And NFS Ganesha is a user space NFS servers. It has support for different versions of the NFS server. It has a modular architecture. It has provides a pluggable file system abstraction layer that allows for various storage backends, well, including CFFS and GlassFS. And it also have another interesting features, such as dynamic export and export update with divas. It can manage huge metadata caches because it's in user level, so it has access to memory in a different way. It provides simple access for other user space services, such as Kerberos, LDAP, which is pretty useful. And again, it's open source, so for your storage, open source storage for your open source cloud, you have NFS Ganesha for NFS Shares, which is also open source. And why NFS Ganesha? Why you are going to use NFS Ganesha if you have the native driver for CFFS? Well, if you want NFS backend, if you want NFS back with an open source storage technologies, then NFS Ganesha works for you. And if you want to leverage any existing Ceph deployment while keeping your NFS shares, because you have already workload using NFS shares, then you can use NFS Ganesha. And now I'm going to lead my colleague here, Romana, to introduce you on the CFFS native driver.
Thanks, Victoria. Today I'll talk about the current state of CFFS drivers in Manila and how we are evolving into a driver that can work in multi-tenant workloads. First up, I'll talk about the CFFS native driver, then move on to CFFS NFS driver. The CFFS native driver was introduced in the Mitaka release. It's been there for a while. It works with Ceph versions of Joule or later. It creates shares backed by CFFS that can be accessed via native CFFS protocol. So you need Ceph clients in the OpenStack VMs that have direct access to the storage backend. So what that means is you get native CFFS performance, but because you need direct access to the storage backend, you need the clients to be trusted. So that makes it useful only for certain use cases of private clouds, but not for public clouds. You need to keep that in mind. There were bug fixes since the Mitaka release. The CI is pretty stable. So it can be used by, I think it should be used by upstream developers and testers as their first choice of backend when they're developing stuff with Manila, if they're familiar with Ceph. So the numbers don't lie. We can see that. Even though this is a building block driver, it already has a good adoption rate. OK, so later today, there's this talk by CERN on how they're using this building block driver. He's right there, so Ani. OK, CFFS driver in OpenStack is a control plane service, like other OpenStack components. You have an OpenStack tenant. He issues a HTTP request to create a share. and the driver goes to the backend, and creates directories, CFFS directories, which correspond to shares. It sets a quota on it corresponding to the share size, and you create those CFFS subdirectory in unique RADOS namespaces. And after that, the tenant wants to authorize certain CEF auth IDs access to the share. So what does this, the native driver and the vanilla service authorizes the CEF auth ID to access the share and returns a secret key back. Okay, typically the OpenStack user interacts through the Horizon GUI. So I've taken a snapshot here. You can see that snapshot of the dashboard. Here you can see the person has created a CEF share. He's chosen the protocol as CEFFS. He wants a size of 5 GB. It's been created, it's available. Then he gets back a share location, which is a conjugation of CEF monitor addresses and the directory path. After that, he would ask for certain CEF auth IDs to be given access to the CEF subdirectory, the CEFFS share, and then he'd get back a secret key. Knowing all of this, he can now mount the share. So in the data plane, not surprisingly, it's very similar to how you'd use CEFFS, only that you have the CEF clients running in the OpenStack Noah VM. For data updates, it just goes directly through the OSDs, and for metadata updates, it goes through the MDSs of the CEF backend services. Just reiterating the points, because the clients are directly connected to the CEF public network, we are kind of dependent on the clients that they be trusted, and you rely just on the native CEF authentication system. There's no single point of failure in the data plane because you just rely on the CEF server daemons. And besides this, we worked on getting this working in a, not just DevStack, but also in a O deployment. So work was done to make sure that O can deploy the CEF MDSs, but it as composable roles. So what that means is you can place it in the node you want. So care must be taken so that CEF MDSs don't affect other services. So you need to be careful about that. You don't want your CEF MDSs running along with the OSDs. Doesn't make sense. So you typically, it's better to run it with the CEF monitor services. And also, if you run it with Python services, the OpenStack services, you need to be careful. You don't want them to affect each other. So that work was done. The other thing we figured out is how do we do the networking. It wasn't super complex. So typically, you'd have the OpenStack tenants in, OpenStack VMs in tenant-defined private networks, which are private namespaces, which are not connected to the public network. So you'd have to connect them through the Neutron router, which connects to the external provider network, and then that's the public network. So and then we'd want these tenant VMs to access the storage public network because we need the tenant VMs to directly access the CEF storage network. So what you can do is have another NIC on the tenant VM that is on the storage provider network. It's easy to set up. We have documented that. The patch is in review, so hopefully the last link, it gets merged. There are other links here that you can check later. Moving on to the CEFFS NFS driver. This is a step towards building something that works in multi-tenant workloads. It creates shares, NFS shares backed by CEFFS. It allows NFS clients in the OpenStack VMs to talk to the CEFFS backend in a more secure way. It does not allow direct access to the storage network. The access is mediated via NFS Ganesha gateways. So that's good. The patches are still being reviewed upstream, but hopefully you can get it in the Pike release. It works with Ceph Kraken or later, and you need the latest version of Ganesha. Okay, in the control plane, it's similar, very similar to the diagram I showed before. So the tenant wants to create shares, and the native driver creates CephFS subdirectories which map to the shares, returns the export location back. And now, instead of authorizing Ceph auth IDs, you'd want to authorize certain IPs. So what that does is, once you send that request, the native driver issues calls to the Ganesha server, creates export entries on disk, manipulates them as per whatever the user requested, and it sends dbus signals so that Ganesha is immediately aware of the new access list. You don't have to restart Ganesha. So that's very useful. OK, in the data plane, now you see there's a gateway in between, which is good. The server daemons do not introduce a single point of failure. But if you have a single Ganesha gateway, then that introduces a single point of failure, which is not good. So there is work being done by the NFS Ganesha community to make it HA in an active-passive mode first, and then slowly you'd want to do it active-active, but that's the first step. OK, we haven't done this yet, but we kind of figured out how we'd want to do this in OOO. We'd create what are this called? Heat templates to deploy NFS Ganesha wherever you want. Again, care must be taken to make sure that NFS Ganesha doesn't affect other services. It's in the data plane. It might have, it is a bottleneck. So the deployer needs to make some compromises. Does he want it to run along with the mons, MDSs? Yeah, that's up to the deployer. Right here, for the what we propose, at least for the first iteration, is run the Ganesha service along with the share service. That way, Ganesha is already connected to the Ceph public network, the storage network. So that's taken care of. What we need to make sure is Ganesha is is accessible to the tenant VMs. The way we do that is have Ganesha, connect to the external provider network. Yeah. So we are pretty sure that this works. Just that you need to be careful about how you want to have all these services deployed in different nodes. With that, I let Tom take over. He's going to talk about the future work. He'll talk about where you want to place the NFS Ganesha servers, how you want to go about it to make it all a complete solution.
All right. Thanks, Ramana. So yeah, I get to talk about where we're going, which is somewhat speculative. My perspective is as I'm responsible in general with OpenStack and turning cool upstream ideas into product to a great extent. So I'm interested in making something that not only we can play with, but that we can stand behind with customers and support. And right now, these are, from a Red Hat perspective, we call these tech preview features at the moment. So we're thinking about how to productionize things fully. So I'm in, though my perspective isn't the only valid one. So I'll be opinionated, partly in the idea that I'll flush out other opinions and that get valuable feedback. When I talk about what we're doing and where we're going, that's our thinking at the moment. Can shift, right? And also, this is an open source project. There's much room for parallel efforts. A lot of work to do on this front. Other people develop something cool. We'll be glad to use it. With that said, when we think about that last picture that Ramana showed us of what we want to do in Pike, the work that he and his team have done on CephFS team that we've done with it to integrate it into Manila is solid, and that's working out. The interesting part, that's very interesting stuff, maybe more interesting stuff, but the critical stuff is to figure out how to deploy it in a way that works from a product perspective. So when we think about that picture, which for Pike, where we place the NFS Ganesha gateway on the controller node, which we're doing for various reasons to have more to do with OOO than anything else. There's some things to like and some things not to like. So as Romana said, we've separated off the user VMs from the Ceph public network, which is a critical first step. And we have, I'll mention, we have pretty good separation of tenants from one another just by Neutron these days. This didn't used to be true, but Neutron security groups work well. And EB tables will prevent stuff in the typical OVS and so on will stop the ARP poisoning attacks and stuff that people worried about before. And when we talk about that public network, this isn't out in the world or anything. This is the, one of the, this is your public network within OpenStack. But things we don't like here is we have a poor man's HA for Ganesha, which is part of the reason we put it on the controller node right now, because we have other services under there under PCS CorelSync control. And we can do the same thing without yet having the NFS Ganesha work that we're relying on in the future for that Romana alluded to, by using, just hooking it into the HA failover there we have. But it's a relatively slow failover. We reload the exports from the Manila database rather than sharing state between multiple Ganesha servers and so on. So it's something we can do now. And the other thing I don't really like is we've really mixed control plane and data plane functions. The controller node is for putting control plane functions, and we've put a Ganesha service, which is in the data plane, on there. We want to be able to place and scale data plane services with data plane resources and data plane load. So this is an interim step, what we expect to be able to do for Pike. As Romana mentioned, we had to be kind of careful. Ganesha can be resource hungry. We may have some isolation issues, noisy neighbor type issues and so on that we need to work with. But it's a step, and it's out there. It's going to be in there in Pike, and people can use it and play with it, give us feedback, fix things themselves and so on. Now, where do we want to go? We want to, if you have an opportunity, I have references at the end. There's a talk by Sage Weil, if you haven't seen it, from the Tokyo OpenStack Summit. It's got the word containers in it, but it's got Manila and Ceph in it. There's a talk by John Spray from the Austin Summit on Manila and Ceph FS, on which both of they give this target, which is there's an address family, VSOC address family, which is there's a paper from Stefan at the end. You can read all about it. But basically, instead of putting NFS over TCP, we put it over AF VSOC, which and deliver through a Ganesha gateway is the way we're thinking now. Deliver shares into a QEMU hypervisor, okay, and then from there to the tenant. So when you look at this picture, there's a top half and a bottom half, and the north half of it, I mean, the picture's similar otherwise, but we've moved the Ganesha servers over onto the compute nodes with the clients that they're serving. And they're serving up through the hypervisor. Ganesha is still involved in the path, okay? And this is you can read all about it and learn more about it in the references at the end. But the critical things about this is there's a lot to like. And this is where we want to go eventually. Okay, we still got user VM separated off from the Ceph public network. We still have a good tenant storage path separation. Now we don't even have Neutron involved in that. It's all done through the hypervisor. There's no shared network involved. The resource demands for Ganesha have no control plane impact. We're over on the compute nodes. They scale, and this is a critical thing for me, they scale proportional to the compute demand. Okay, so we're putting one per controller. We have n consumers per controller. We want to add more consumers, we add more controllers. So we'll add a Ganesha server at the same time. So we're not doing it by some control plane thing. We don't need that PCS CorelSync machinery from the control plane that we're trying to move off of in OpenStack in general. And we don't have dependencies on Neutron or L2 switching. Now, critical observation for me is that the consumers of a mount are in the same HA, same hardware failure domain as the server. okay, in this little picture. I want to keep that as we move forward. What's that mean? That means unplanned outages at least, and actually in this case I think even migrations. If the server goes away because of a hardware failure, its consumers are also gone. So that greatly simplifies a lot of the HA issues. There's a bunch of dependencies getting from here to there. We can talk about it more. It's a long subject. But what it means is that we're not, except in perhaps the most optimistic of scenarios, going to have this ready for Queens. So what do we want to do in the meantime? One of the possibilities that has to be considered is that we leverage the Manila service module, which is server instance module, which is used by the Windows driver and used by the generic driver that Victoria alluded to, basically what we would do is put Ganesha in what they call share servers, which are administratively run service virtual machines. They would be gateway. We would still have them on compute nodes, but they're spun up dynamically by Manila. Okay, and they, this is a model that's well understood in the Manila community. If you see the buzzword DHSS equal true for driver handle share servers and so on, we're talking about that. So people say, well, why don't you do that with Ceph? CephFS. Okay. It gives you good isolation of VMs from the Ceph public network, and it gives you a good isolation of tenants from one another. But here's what I don't like about it, at least. It's a very expensive, heavyweight approach for tenant isolation, because you make a service VM one or more if you were ever to do HA. It doesn't supply HA right now, so we'd have to build that. Per tenant. I'm in the RDO cloud the other day. Guess what? I have my own tenant project. Just like in a Unix machine, you might be user tbaron and group tbaron. There's project tbaron. So there are at least as many projects as users in that cloud, which would mean that in order, if they were all consuming NFS, I would need at least as many service VMs as users in that cloud. It's not the only way to build a cloud. A lot of them have fewer numbers of projects. It's one extreme of the spectrum. But it doesn't, this does not scale well with it, and the scaling doesn't fit with the actual demand on the computers. It puts a single point of failure in the data path unless we go and do the work to build HA for it, because that's not in there. The solution right now involves playing with Open vSwitch or Linux Bridge in order to stitch things together to make that the lines on the diagram, previous diagram, work, from the service VMs into the tenants. Guess what? Open vSwitch and Linux Bridge aren't the only switching technologies in town. We would need to write plugins for everything that we could possibly support. I'll skip some of the other stuff, but I can. Anybody wants to talk about this? The reasons I don't like this solution for us, for what we're doing, it's fine for as a reference driver. We can go into it more, but it's ignorant of. The code was written a while ago. It doesn't know about L3HA. It doesn't know about distributed virtual routing. There's a lot of work to do to make this work as a production quality thing. So what we thought we could do for Queens is take some of the good stuff move in the right direction, towards the hypervisor mediated solution, even though we don't have all that yet. So we want to move the Ganesha servers over to the compute nodes, one per compute node. Keep the failure domain stuff that I talked about before. But we will still rely on connecting through Neutron network, through the external provider network. So the bottom half of this picture is like what Romana had earlier. And this will move us towards the direction while we work in parallel to get the VSOC stuff ready post-Queens, most likely. The big challenge, I listed the things I like, and I'm not going to cite them again. It's the similar stuff. A lot of it we get to carry over from the VSOC solution. But what we have to work out is we only rely right now on convention and information to say that you're going to use the export server from your compute node rather than from another. So we had to figure out a way to, through documentation, communication, tool building. I've toyed with the idea of figuring out how to do IPv4 linked local addressing, but I want to figure out a way to, as best as possible, get the kind of thing you have in VSOC where the consumer of the mount is on the same node as the provider. It may be a matter of education and just telling people use that export rather than others. So that's what we've got to figure out. Here are a bunch of references for your leisure reading that are, I encourage you to read. In particular, the first and third are the talks I talked about if you want to see, get a feel for the VSOC solution. Want to thank all the teams. That one of the really fun things about working on this project for me is I work on the OpenStack team, as does Victoria, and we've gotten to know a fair number of the people on the CEFFS team here, and now starting on the NFS Ganesha team. It really rocks to get to do this and work with people on this kind of thing. So with that, I think we can take questions.
Yep, thanks.
Oh, and would you make sure and use mics if you have questions or comments, because this is being recorded? No pressure. That's right.
Hi, I like to talk, but I have a question. It seems like there's a lot of extra complexity in deploying NFS Ganesha here, as opposed to fixing the kind of support for multi-tenancy in core CEFFS. Are there thoughts about avoiding this extra layer and fixing CEFFS to support multi-tenancy and security in a better way, more natively? This might be a sage question.
I would ask Rick Wheeler what he thinks about that. I'm partly joking. I am joking. One thing, though, it seems to me, just speaking offhand, my thought is it'd be a fine thing to do and a great thing to do. And when it's done, then perhaps we, as a downstream provider of a distro, I'd be more inclined to say this is something we feel like we could just have anybody support as opposed to just sophisticated people at CERN or something like that. That we could support anybody on that, and you know, if we had that kind of protection. Of course, I'm over on the OpenStack side, so I would look to the CEFFS developers to build that. Now, that said, another thought, though, is an NFS is a pretty ubiquitous and well understood protocol. So we need to do that independently anyway. We have people out there who understand NFS. They had, NFS 4.1 is pretty awesome. Avoid 4.0, please don't use it. There's just a lot of the market that we would be serving that wants NFS as well. So I think having both would be great.
Right, and you know, I do agree, just to kind of answer my own question. I mean, NFS has an interesting role for people who don't have CEFFS natively baked into their image. That, I think, is the longer term thing that you're kind of alluding to. Even Windows clients have it. The other thing I'd suggest thinking about more is PNFS, you know, when you have PNFS support, because then you split the control plane and data plane from, you know, metadata updates versus data flow. So that'll be maybe more interesting as well.
Yeah, and we have, as some of you will know, you will see people here well known in the NFS world working on this stuff. You know, kernel maintainers for NFS and so on. So we get to work with some really great people on this stuff.
Guys, great talk. I love it. Have you done any, so do you know like how much CPU memory network I would require for NFS Ganesha service? Like if you have anything, numbers?
At least, I mean, I'm not aware of it, but I'm sure they've been testing it with the Rados gateway. Sorry, I don't have.
Okay. I can test it.
And I think that's something we need to do.
Yeah.
And we've alluded to the fact that there could be noisy neighbor problems and so on, because it could use a lot, right? It's really good at caching. So other people know more about this than me, but I would say it stands to reason that it could consume a fair amount of memory. And we may, even if we don't go with the service VM per tenant type model, want to run it in a VM or a container or something to help manage, or you know, just C groups, do something to control how much of a server it how much of a compute server it uses up if you're going to also run compute VMs on it.
Also,
Yes, VMs.
there was work going on CFFS does its own caching, and NFS Ganesha also does some caching. So we tried turning off some of Ganesha's caching, attribute caching and entry caching. So we are looking to that as well, optimizing that, but that's still early days.
So Rick has already paved the path for my questioning. So I wanted to know what's the scope of multiple CFFS file systems, so that another way to achieve multi-tenancy would be to create a separate CFFS file system and then totally avoid Ganesha or NFS or anything like that.
I think, that's one of the ideas we had. I mean, that's in the works, multiple CFFS. It's being developed. I think it's still experimental even upstream. Right now for Luminous, I think Sage will update you. It's more about getting active MDS working first, and then we'll think about multiple CFFS, but we have thought about that, yeah.
So another question with regards to NFS, right? So there's an NFS server which is inside the kernel as well, and if someone wants to use this CFFS kernel module, will this work with the NFS server which is already in the kernel instead of using the user space Ganesha version?
You can use the Manila driver for that.
But yes, it could be done. And in fact, if you look at some of the earlier slides from Sage and so on, it doesn't say definitively, but it suggests that that would be done. I think work with Ganesha right now is more agile, working in user space, for one thing. There's also waiting on kernel things to get ready and be perfect is not the quickest way forward in our timeline. Could it happen eventually, and might there be a bit better advantages? Yes, we can see. There are a lot of advantages to using Ganesha for high read workloads and stuff like that anyway, given the way it does caches.
Okay. And the last question on the same trend is, what's the state of support for multiple MDS servers for this FFS?
You want to address that?
Yeah. I think Sage would, can give you a better picture. But yeah, since I work in the FFS team, I can tell you that there was at Wall Talk, there was this talk by Patrick Donnelly where we were characterizing how active MDS works. What we figured that the dynamic load balancer, which balances the metadata, it's not working as well as we want it to be. So, so right now I think the idea is to have to give the admins the capability to manually pin certain subtrees to certain MDSs. So yeah.
But it is showing up. It's just not, in Luminous. You're going to have active. It's just not balanced ideally yet.
Okay, thank you.
Is that accurate, Brett? Yeah.
That's what they told me. Arne?
Thanks a lot for the nice presentation. I have a couple of comments, actually, not so much questions. So on the
everybody go to his presentation on CERN later.
Yeah, if you don't have left already, it's like almost the last presentation of the conference. So for the multi-MDS, we were looking to this. This actually, as Tom just said, it's showing up. It seems to be working okay from what we see. So it's actually pretty cool. For the NFS versus CFFS thing, so it's actually pretty important to have NFS support on top of NFS, on top of CFFS, because many users, at least for us, they are pretty conservative and they know NFS very well. So if you have CFFS as a backend and NFS as a frontend, that actually helps with the adoption. There are also products that require you to have an NFS file system for warranty or licensing issues. So that's pretty important. One thing about the service for the Ganesha service and where it should be on the controller or on the hypervisor or on a service VM, you said that you don't like it so much that there's an additional service VM that would be spawned up to this. Actually, I don't think that's necessarily a bad idea for a couple of reasons. So one is that if you put it on the hypervisor itself, the hypervisor may be designed in a way that if you put the VMs there, there's very little resources left for something to run on the hypervisor in addition, right? And if you have something where you're not really sure how much CPU it uses or how much memory it uses, it's actually pretty risky to put something there. And as soon as you have one user there that actually does NFS, he affects everyone else because then you run out of memory or CPU or something. So let me just briefly finish. So while for other services, sorry.
No, I'm rude.
For other services, we do the same thing. So, for instance, we have a Magnum service where people create virtual machines in order to have a Magnum cluster where they run Kubernetes on top, for instance, and they don't get a centrally managed Magnum cluster. They have to take this out of their own resources, similar to what you would have if you would spawn off a service VM. So if you have tenants that are like big enough, you don't need like many Ganesha servers in there, right? It's like one VM that you have in your tenant where you may have like hundreds of VMs. So I think the idea is actually not too bad to have.
And that's a great clarification. My concern is less with it being a service VM rather than a native process than with doing one per tenant. Is that scaling concern is the bigger thing. And in fact, I did kind of as an aside say, and we may want to contain the resources via C groups or a container or a service VM to do that. So thank you.
Just last question. So completely unrelated to your talk. So any work going on CIFS or SMB? Do you know?
SMB support for SFFS?
Yes.
I think in the CI we have tests running, but I don't know if there's active development. But there are tests running, and I don't know. There are issues with SMB that we figured out. We want to improve that.
And from a product perspective, we observe more people asking for NFS with SFFS backend right now. So if there are people who are very interested in CIF service from that, that's valuable information. A lot of this is part of the reason we do this kind of thing is to get feedback and hear from people. So, you know, talk to us.
All right.
Unfortunately, that is the end of the time. We're going to have to cut it off. Oh, okay.
Awesome. Thank you.
But thank you, everybody, for coming, and thank you very much for a great talk.